Hello everybody, how are you? I'm Mr. Islam Ayman and I'm going to be your math teacher for this year. We're going to talk about real functions at this video. But first of all, we have to remember very important information about relations and functions. For example, show with reasons which of the following relation represented by the shown arrow diagram represents a function. If so, mention each of the domain and the range for every function. Let's see the first relation R1. We have x and y. We have four elements in x, a, b, c, and d. All the element of x has one image at y, but b has no image, so R1 is not a function because there is no arrow from b, which belong to x, to an element in y. For R2, or the second relation, we have images from all the elements of x, but the element a has two images, 1 and 9. So R2 also is not a function because there are two arrows going from a, which belong to x, to two elements in y. For R3, or the third relation, we have four images from A, B, C, and D. So we can say that R3 is a function because there is one and only one arrow drawn from each element in X to a corresponding element in Y. Okay, so we said that the third relation R3 is a function. We need to get the domain is the element of X, A, B, C, and D, and the range is the images 1, 3, and 5. Okay, so what's the real function? It's a relation from X to Y. And to determine whether the relation from X to Y is a function or not, we're going to do that with two ways. The first way is graphically and the second way algebraically way. Let's start with graphically way by using the vertical line test. We are going to draw a straight line, and this straight line must intersect with the graph of the function at one point only. For the left graph, we draw the straight line and it intersected with the curve at one point, so it's a function from x to y. And for the right one, it's not a function as a straight line intersected with the graph at 2 points. So if the line intersected with the graph or with the function at 1 point only, it's going to be a function. But more than that, it's not a function. Okay, now with the domain. How can we identify the domain of the function from its rule? The first type of functions is polynomial function, like constant function, linear function, quadratic function. All of these functions, its domain is R. Its domain is R. The second type is rational function or fractional function. Its domain is R except the set of zeros of the denominator. So we have some functions which are rational functions or fractional functions, have you said? And we're going to find the domain of each of them. We're going to take the denominator and it's going to be equal 0. For the first one, x equal 0, so the domain r minus 0. For the second one, x minus 2 equals 0, so x equal 2, so the domain is going to be r minus 2. For the third one and the fourth and the fifth and the sixth ones, we are going to get the factors of the denominators and solve the equations, and the domain is going to be like that. Okay, now let's go to the root functions. There is two types of the root function. The first type, when n is an odd number, like the square root, the fourth root, the sixth root, then the domain of the function is going to be any number greater than or equal 0. So If n is an even number like square root and the fourth root and the sixth root, the domain is going to be greater than or equal 0. What if the root was odd number like cube root? Then the domain is going to be R, just like that. State the domain of each of the real functions, which are defined by the following rules. Number 1, if x equals square root x plus 2. This is square root, it's an even root, then the function defined where x plus 2 greater than or equal 0. So x going to be greater than or equal negative 2, then the domain is going to be an interval start with negative 2 to infinity. The second one, it's a square root also. So x plus 2, x power 2 plus 5 must be greater than or equal 0. Okay, can I get a square root for any negative number? No, I can't. So there is no number can be substituted in that rule or in that root, which makes the problem is going to be wrong. So our domain is R, and so on. So any even root is going to be greater than or equal 0, but any cube root is going to be R, just like number 4, fx equal cube root 9 minus x power 2. It's cube root, so without anything, our domain is going to be R.